This lesson is on graphing and solving quadratic inequalities. In the last lesson, we learned how to graph a quadratic equality, where you have something like y is ax squared plus bx plus c. But we really prefer to write it like a times x minus b squared plus c. These are different a's, b's, and c's than were there before. So we could graph this, and here I'll go ahead and put my axes down. And I'll graph this in black. That doesn't look very good, so I'll try that again. That's decent, I guess. So that's y as some function of x that's a quadratic. And actually, I'll go ahead and here, instead of saying y, I'll just call this a function of x. And black is the case where y equals that function of x. The point of quadratic inequalities is, well, what if y doesn't equal the function of x? What if instead I have y has some not equal relationship with the function of x? And this could be things like greater than or equal to, less than or equal to. It could be any of these. Let's say y is greater than the function of x. That's the red color. If it's greater than the function of x, that means it never quite meets the function itself. So we resemble that using dashed lines on the function. Because we're like getting close, but we're not quite touching it. And I'm also going to shade in everything that's above, because we have y being greater than that function. So here I have y at some point on the function, but I'm thinking at everything greater than that. So all of this can get filled in. So this is the graph of a quadratic inequality in like the function form. But what if I just didn't have y having some relationship to a quadratic? What if I had that some quadratic had some relationship with the number 0? And note that the reason I say 0 here is because let's say it was 1. Well, if it were 1, then I could really just change this c. I wrote down the wrong c. This is actually a different quadratic where I have a x minus b squared plus c minus 1 has some relationship to the number 0. So here I have my relationship, and you might have noticed that I didn't just put a gray box like I did before. I put a gray kind of circle resembling whatever the inequality is. And that's because this is written in a different way than my y inequality f of x. In fact, it's the other way around, because what I have on the left here is just f of x. So in other words, I'm saying f of x has some relationship with the number 0. If I wanted to put the 0 on the other side so I could get something that looks like my y over here, then I'd have to switch what the sign looks like. For example, if I had a less than over here, f of x is less than 0, well, that really means 0 is greater than f of x. So that's like over here, if I had greater than, and I looked at the case where y is equal to 0. So now let's look when 0 equals y is greater than f of x, when I'm trying to solve the quadratic that I was given down here. I can look at my graph. I can look at the line. So I've already drawn y is greater than f of x. I've already showed that here. That's what I drew earlier. Well, now I'm saying y is equal to 0 specifically. So let's look at that line where y is equal to 0. What the question is really asking is, when is this true? When is y, which is greater than f of x, equal to 0? So when I draw this, I'm saying, when is it shaded in? Well, it's shaded in when my value of x is between some number and some other number. And this will correspond to a point here, and this one corresponds to the point here. Notice I didn't say less than or equal to, or like between or equal to, over here. That's because that's not what my function allows. My function doesn't include the line. it gets extremely close, but it never quite includes it. So that's how I would write it. And that would be the solution.